Hello folks, we are back with the part 4 video of this exercise, miscellaneous exercise. Last time we continuously finding the derivatives. That's what we are doing. So we will be continuing with that process of finding the derivative. Last part we found out the derivative of question number 5. Now we are here with the question number 6, and question number 6 says that y equal to cot inverse of root of 1 plus sin x plus root of 1 minus sin x by root of 1 plus sin x minus root of 1 minus sin x. This question is a beautiful confluence of all the trigonometric ideas that we have learned maybe in the last year and this year and so on. So our intention is somehow we will modify this bracket in such a way that we should get cot of some angle over here inside the bracket, so that cot inverse and cot, they being inverse functions, you will have your function modified. That is our attitude. Somehow get this bracket simplified in such a way that you get it as some cot of some function, and then the working becomes simple. So we're going to move across like that. Just to start with, let's consider the 1 plus sin x. Let's see if that can be modified in some way. 1 plus sin x, if we all carefully observe, the 1 could always be written as cos squared x by 2 plus sin squared x by 2. There's no harm in writing it like that. So that is how we are writing the 1. And we can modify this 2 sin x as 2 sin x by 2 cos x by 2. What we are trying to do by this is, somehow if we can get this as whole squared, then that whole squared and this root can make that entire thing quite simple. So that's our intention. As a result, when we carefully observe the 1 becoming cos squared x by 2 plus sin squared x by 2 and sin x becoming 2 sin x by 2 cos x by 2, this entire expression is actually cos x by 2 plus sin x by 2 the whole squared. Incidentally, as a result, our root 1 plus sin x can be easily modified to just cos x by 2 plus sin x by 2, because the root and the square, they will do away with each other, and you will get it as cos x by 2 plus sin x by 2. So that's a beautiful way of simplifying the root of 1 plus sin x as cos x by 2 plus sin x by 2. Now similarly, it's very clear that from the way that we have written like this, similarly the root of 1 minus sin x will also work as cos x by 2 minus sin x by 2, just on the same lines. So what happens? We'll check what happens to our y value. Y value becomes cot inverse of 1 plus root of 1 plus sin x. For us, it is cos x by 2 plus sin x by 2. And root of 1 minus sin x, we have got it. It is cos x by 2 minus sin x by 2. And so on. Even the denominator. Denominator is cos x by 2 plus sin x by 2 minus, because minus is there, the terms inside, they're going to change their signs, and you're going to get it as minus cos x by 2 minus of minus plus sin x by 2. What is the advantage? The advantage is that the sin x by 2 sin x by 2 from the numerator, they can cancel. The cos x by 2 cos x by 2 from the denominator, they can cancel. So as a result, we have the whole thing modified, and it now modifies to the bracket term. It is getting modified, and let's see how the modification is coming. The modification comes like this. Y therefore is cot inverse of cos x by 2 plus cos x by 2, we all know, is 2 cos x by 2. So this is becoming 2 cos x by 2. And the denominator is going to be 2 sin x by 2. So the 2, they can cancel each other. As a result, we are left with cot x by 2. We observe cot inverse and cot. They are inverse functions. As a result, we are left with x by 2. So your y is now becoming x by 2, which means y is half x. So when we are planning to take the derivative, dy by dx, we know the constant always comes out of the derivative, and you have to only find the derivative of x. And derivative of x, we all know. Derivative of x, we all know, is just 1. So that way, your derivative becomes half. So overall derivative of this function is half. Though it was directly not visible, we have done a mathematical substitution and mathematical substitution of a proper formula, and we are able to simplify, and this is how we are getting the answer. That's all in this video. With the next problem, we meet in the next video. Thank you.